residues class. I'll try to complete today. And first, I'm taking one problem from CSR.NET. Suppose C is the circle. Suppose C is the circle. Modulus of Z is equal to 1 positively. Modulus of Z is equal to 1 positively oriented, and f of Z is equal to e to the power of Z divided by Z into Z minus 2 into Z minus 3 into and so on Z minus 9. Then the value of the integral over C f of Z dz.
ఈ నెంబర్ కు పంపించండి.
F of Z dz.
మీ నేమ్ వాట్సాప్ నెంబర్ పెట్టండి.
Now these are the we are given options. First option minus pi I by 9. Second option pi I by 9 factorial. Third option minus 2 pi I by 9 factorial. And fourth option 2 pi I by 9 factorial. Here first option is minus pi I divided by 9 factorial. Okay. We can observe here the circle is modulus of Z is equal to 1, centered at origin, and radius is 1 unit. Okay. So clearly when the denominator is 0, so Z equal to 0 comma 2 comma 3 2 and so on and 9 are simple poles. They're all simple poles. But Z is equal to 0 inside C, inside the circle C. So we have to calculate the residue at Z equal to 0 only. So residue of the function f of Z at Z is equal to 0 is equal to limit Z tends to 0 Z into f of Z, that is e to the power of divided by Z into Z minus 2 into Z minus 3 and so on Z minus 9. Okay. Here Z will be cancelled. Apply Z equal to 0 here. So we get the numerator is 1, denominator is minus 2, minus 3, next term minus 4, up to and so on minus 9. These are all 8 terms. So 8 minus, even minus means positive. So 1 by 2 into 3 into 4 into and so on into 9. Nothing but 1 by, this can be written as 1 into this. So this is 1 by 9 factorial. So by the definition of residue, integral over C f of Z dz is equal to 2 pi I residue of the function, that is 1 by 9 factorial. So that is equal to 2 pi I by 9 factorial is the right option. So fourth option is the right option. Okay. Now I'm taking another problem from, I'm sorry, it is a net question. Set question. Now I'm taking another set question. Suppose C is the circle. Suppose C is the circle. C is the circle. Modulus of Z is equal to 2 positively oriented. positively oriented. Then the value of the integral, the value of the integral, integral over C dz divided by z square plus 2zi
ఏమోనా
minus 1 is. We have options. First option 2 pi I, second option minus 2 pi, third option 2 pi, and the fourth option is 0. Okay, we have 4 options here. So first of all, we have to find the singularities. For singularities, we have to equate the denominator as 0. For singularities, we should equate denominator, that is z square plus 2iz minus 1 is equal to 0. This can be written as z plus I whole square is equal to 0. While expanding, we'll get this only, I square is equal to minus 1. So here z is equal to, therefore z is equal to minus I is a pole, is a of order m is equal to 2. M is equal to 2 is a pole of order. At this pole, we have to calculate the residue first. Residue of the function f of z. Here f of z is nothing but we are taking f of z is equal to your 1 upon z square plus 2iz minus 1. Okay. At z is equal to minus I, that is equal to limit z tends to minus I 1 by 2 minus 1 2 minus 1 factorial into d by dz of z plus I whole square into f of z. F of z function is 1 by z square plus 2iz minus 1. This can be written as z plus I whole square. This term will be cancelled. So this is equal to limit z tends to minus I. This is 1 and the derivative of 1 is 0. So this will be 0. The residue will be 0. When the residue will be 0, then integral over C f of z dz is equal to, by definition of residue, that is 2 pi I into 0. So that is equal to 0. Fourth option is the right option. Okay. Now I am taking another problem. The residue of the function is also from set. The residue of the function f of z is equal to z square plus 3z minus plus 2 divided by z square into z minus 1 at z is equal to 0 is. We have options here. Option 1 is 0. Option 2 is minus 1. Option 3 is minus 5. Option 4 is minus 2. Okay. Now we have to calculate. We are given already z equal to 0. We have to calculate the residue at z equal to 0. Clearly we can observe z equal to 0 is a pole of order m is equal to 2. Okay. Z square into z minus 1 equal to 0 means z equal to 0 comma 0 and 1. So that z equal to 0 is a pole of order m equal to 2. At this pole, we have to calculate the residue only, not the integral value. So residue of f of z at z is equal to 0 is equal to same limit z tends to 0, 1 by 2 minus 1 factorial into d second term m equal to 2 means first derivative d by dz of z square into f of z. F of z is, we can write this is the f of z, that is equal to limit z tends to 0. Here d by dz of z square into z square plus 3z plus 2 divided by z square into z minus 1. Here z square will be cancelled. Now differentiate this function with respect to z one time and apply limit z tends to 0 here. So I'm differentiating this by using u by v formula. So z minus 1 into derivative of numerator, that is 2z plus 3 minus z square plus 3z plus 2 into differentiation of denominator, that is 1 by z minus 1 whole square. Okay. Now apply z equal to 0 here. You get minus 1. This is 3. This is 2. The 1 divided by here minus 1 whole square. This is equal to minus 3 minus 2 minus 5 by 1. That is equal to minus 5. So third option is the right option. Okay, third option. Yeah. Option C. Now I'm taking another problem. It is from TS set also, from TS set. The value of the integral, integral I is equal to integral over C z divided by z square minus dz plus 2 into dz over C modulus of z is equal to modulus of z minus 2 is equal to 1 by 2 is. We have options. Option 1 is 2 pi I. Option 2 is 4 pi I. And option 3 is 6 pi I. And fourth option is 8 pi I. Okay. First, we have to take the circle. I'm considering this circle. Here, take the complex plane, real axis and imaginary axis. It is origin. At 2 units distance, 1, 2, it is the center. This is 1 and this is 3. Okay. Radius is 1 by 2. 1 by 2 means 0.5. So here the radius. Okay. So the radius is 1.25 to 1.5 to 2.5. Okay. So we have to calculate the first singularities. For singularities, the denominator, that is z square minus 3z plus 2 is equal to 0. Okay. While factorization will get z minus 1 into z minus 2 is equal to 0. Clearly observe here, z equal, therefore z is equal to 1 comma 2 are simple poles, and z is equal to 2 inside C. At this C, z equal to 2, we have to calculate the residue. Okay, as we know that z equal to 2 is a simple pole, so the residue of the function f z at z is equal to 2 is limit z tends to 2, z minus 2 into the function f of z. Okay, here the function f of z is limit z tends to 2, z minus 2 into f of z is z divided by actually z square minus 3z plus 2 only. We are factorizing Z square minus 3Z plus 2 into Z minus 1 into Z minus 2. So I am writing just Z minus 1 into Z minus 2. Okay. So here Z minus 2 will be cancelled and applying Z is equal to 2 here. 2 divided by 2 minus 1, that is equal to 2. Okay. This is the residue, but we have to calculate the integral value, that is integral over C f of Z is equal to, by definition of residue, 2 pi I into 2, that is 4 pi I. Okay. So our required answer is second option is the right option. Okay. Now I'm taking another problem. Before going to take this problem, as we know that Liouville theorem, already we are discussing Liouville. The Liouville theorem is every bounded and entire function, every bounded and entire function must be constant. It should be bounded and entire. Entire means analytic at everywhere. Okay. This is the theorem, Liouville theorem. Direct statement could add to practice which so you have to remember bounded function and entire function will gives the constant. Okay. Gives the constant. According to this, we are given one problem from set. I'm taking that. If an entire function f of z, if an entire function f of z if an entire function f of z is bounded in absolute value for all z. Absolute value means modulus of f of z value. Okay. Then f of z is equal to, we are given. Okay. We have options here. First option, constant. Second option, e to the power of z. Third option, 1 by z. And the fourth option is z. Absolutely, we have to see your entire function which is bounded. Entire and bounded function to be constant. So f of z is equal to constant. According to Liouville theorem. F of z is equal to constant. Okay, this is the direct statement of Liouville theorem. Okay. Now I'm taking another problem. This is direct question, you can calculate directly. So just asking the formula. Okay. I'm giving if f of z as a pole is a set question. If f of z as a pole of order 3 at z is equal to a. Then residue of f of z is equal to. Okay. Is equal to. Direct question అండి. జస్ట్ మన ఫార్ములానే అప్లై చేయండి. z ఈక్వల్ టు z0 is a pole of order m అన్నప్పుడు m ఈక్వల్ టు 3 సబ్స్టిట్యూట్ చేయండి. z0 ఈక్వల్ టు a సబ్స్టిట్యూట్ చేయండి. ఫార్ములా యాక్చువల్లీ ఫార్ములా ఏంటి? Residue of the function f of z is equal to, I am not taking the options here. Z is equal to a is equal to limit z tends to a 1 by 3 minus 1 factorial second derivative. That means 3 minus 1. That is d square by dz square of z minus a whole square into f of z. Okay. So this is equal to, we can write 1 by 2 factorial is 2, limit z tends to a, 1 by 2 d square by dz square of z minus a whole square into f of z. Okay. This is the actual original formula. లేదంటే దీన్ని ఇలా కూడా రాసుకోవచ్చు అండి. 1 by 2 is constant d square by dz square of dz square of z minus a whole square f of z at z is equal to a. ఇలా కూడా ఆప్షన్లలో ఇలా ఇచ్చారు. ఓకే. సో this is a direct question. Now I'm taking another problem from set the residue of the function f of z is equal to sin z divided by sin z anything whole cube. Second, is wrong here. A square z equal to a is a pole of order 3 కాబట్టి whole cube ఎక్కడ వస్తుందండి? యా ఇక్కడ వస్తుంది whole cube 6 whole cube. Yes, is 2 factor. టర్మ్ క్యాన్సిల్ అయిపోయేటట్టుగా ఉంటుంది. Okay. The residue of the function f of z is equal to sin z by z into
సార్ పైన ప్రాబ్లం లో z మైనస్ ఏ హోల్ క్యూబ్ కదా సార్?
అదే సార్ రాశాను సార్ ఇక్కడ.
ఓకే సార్, ఓకే.
z minus a whole cube. Okay. All right. Z minus a. Now f of z is equal to sin z by z cos z at the pole. Z is equal to pi by 2. Z equal to pi by 2. Okay. Just we are given the pole here. At this pole, we have to calculate the residue. Okay. So we have options here. First option 1. Second option pi by 2. Third option 0. And the fourth option minus 2 by pi. First, we have to see the function here. It is in the form of quotient function. Actually, it is originally quotient function. So you can take pi of z is equal to sin z. We no need to calculate the whole. Okay, no need to take the singularities. Just we are given. And psi of z is equal to z cos z. We have to verify the conditions. Phi of z is equal to 0. Phi dash of z is not equal to 0. Okay. First phi of pi by 2. That is sin pi by 2. Sin pi by 2 is equal to 1, not equal to 0. And psi of pi by 2 should be 0. Pi by 2 into cos pi by 2. Cos pi by 2 is 0. 0 into pi by 2 is 0. And psi dash of z. First calculate psi dash of z. That is UV method minus z sin z plus cos z. And substitute pi by 2 here. Psi dash of pi by 2 is equal to minus pi by 2 into sin pi by 2 1, cos pi by 2 is 0. That is equal to minus pi by 2. Okay. So we have formula residue of the function pi of z by psi of z at z is equal to pi by 2 is equal to limit z tends to pi by 2 pi of z divided by psi dash of z, or simply we can write it is pi of pi by 2 divided by psi dash of pi by 2. Okay, just to substitute the values here. This is nothing but residue of the function pi of z by psi of z is f of z at z equal to pi by 2, that is equal to pi of pi by 2 value is that value not 0, that is 1. Denominator value is minus pi by 2, so that is equal to minus 2 by pi. Minus 2 by pi is the right option. So fourth option is the right option. Okay? Option 4 is right. Now I'm taking another problem here. It is from CSR and also set the problem of other state. Just I'm taking the simple problem. Set and also this net problem. Let C is the let C be the oriented. I'm sorry. Let C be the circle described by modulus of Z is equal to 2. Then the value of the integral over C dz by z minus 1 whole square is dz by z minus 1 whole square is. Just take the options here. 1 by 2 pi I, second option 2 pi I, third option 1, and the fourth option is 0. So I have to observe here clearly z is equal to 1 is a pole of order m is equal to 2. It means when we equating for singularities, we have to equate the denominator as 0. So z equal to 1 is 2 times. So it is a pole of order 2. At this pole, we have to calculate the residue. That is residue of the function f of z at z is equal to 2 is equal to limit z tends to 1 by 2 minus 1 factorial into d by dz of z square, z minus 1 whole square into f of z. F of z is 1 by z minus 1 whole square. These two terms are cancelled. So this is nothing but limit z tends to 1. It is 1 by 1 factorial is 1. D by dz of 1, that is equal to 0. Residue 0 means by definition of residue integral over C f of z dz is equal to 2 pi I into 0, that is 0. So fourth option is the right option. Direct question. Okay. We can use a Cauchy integral formula also. Okay. Now I'm taking another problem. It is set question. Same question paper. Set question. The residue of the function f of z is equal to e to the power of minus e to the power of 1 by z, e to the power of minus e to the power of minus 1 by z at z is equal to 0. 0 is. We have options here. Of course, it is a net question and also gate question. Okay, but different options ఇచ్చాడండి. ఇందులో కామన్ గా ఒకటే ఆప్షన్ ఉంటుంది. 1 ప్లస్ e power minus 1, 1 minus e power minus 1, e minus e power minus 1, fourth option e power minus 1. These are the 4 options we have. So first I'm taking the function f of z is equal to e to the power of minus e to the power of 1 by z. So we can write it as e to the power of minus, we have to expand the function e power z expansion. E power z expansion is 1 plus z square by 2 factorial. We know the formula. I'm writing here. E power z is equal to 1 plus z by 1 factorial, z square by 2 factorial plus z cube by 3 factorial and so on. According to this, we have to expand e to the power of 1 by z. Okay, e to the power of 1 by z means 1 plus 1 by z plus 1 by z whole square by 2 factorial become, I'm writing clearly, is 1 plus 1 by z by 1 factorial plus 1 by z whole square by 2 factorial plus 1 by z whole cube by 3 factorial and so on. This is the expansion of e power and e power lo rastundani. So this is equal to e to the power of, I'm separating the terms here, e power minus 1 minus 1 by z plus or minus, I'm sorry, 1 by 2 into z square. Next term 1 by z 6 into z cube and minus అన్ని కూడా మైనస్ ఉంటాయి. So I am writing e to the power of minus 1 into e to the power of minus of 1 by z minus plus 1 by 2 z square plus 1 by 6 z cube plus and so on. Okay, మళ్ళీ ఇక్కడ ఫార్ములా యూజ్ చేయాలండి. e పవర్ మైనస్ 1 ఇలానే ఉంచండి. సేమ్ e పవర్ మైనస్ z ఎక్స్పాన్షన్ రాయాలి. e పవర్ మైనస్ z is equal to expansion 1 minus z by 1 factorial plus z square by 2 factorial minus z cube by 3 factorial, z cube by 3 factorial plus and so. This is the expansion of e power minus z. Alternative plus and minus వస్తాయి. కానీ ఇక్కడ యూజ్ చేసుకోండి. ఇది కంప్లీట్ గా ఈ టర్మ్ మొత్తాన్ని z గా ట్రీట్ చేయండి. కంప్లీట్ ఇట్ షుడ్ బి z. ఓకే, సో we can write it as e to the power of minus 1 into is equal to e to the power of minus 1 into 1 minus this term, completely term. Okay, 1 by z plus 1 by 2z square, I'm at 1 plus 1 by 6z cube divided by 1 factorial. Okay, ఇక్కడ 1 factorial కాబట్టి రాయట్లేదు. ప్లస్ 1 by 2 factorial of 1 by z plus 1 by 2z square plus 1 by 3z cube, sorry 6z cube plus and so on whole square plus and so on. Okay, again and so on. So actually what we have to find residue of the function. Okay, residue by definition of residue, therefore residue of the function f of z at z equal to 0 we have to calculate. That is equal to, by basic definition, your coefficient of z minus 0 whole to the power of minus 1 coefficient. That means z power minus 1 coefficient in the expansion of f of z. Okay. So here we have to observe the coefficient of 1 by z. Z power minus 1 means 1 by z. 1 by z coefficient is minus 1. Here we have minus, sorry, e to the power of minus 1. So minus e to the power of minus 1. ఇక 1 by z టర్మ్స్ ఎక్కడ ఉండవండి. ఇందులో 1 by z స్క్వేర్ నుండే స్టార్ట్ అవుతాయి. నెక్స్ట్ 1 by z క్యూబ్ నుండి. కాబట్టి this is the this is the 1 by z term. That means we have to take the coefficient of 1 by z. This coefficient is minus 1 and we have e to the power of minus 1 term before this. So this is the residue of the function. Okay, just minus e to the power of minus 1 is the answer. So minus, third option is the right option. Okay. Now I am taking another problem. The residues of the function, it is also set to problem. The residues of the function f of z is equal to z square divided by z minus 1 into z minus 2 into z minus 3 at z is equal to 1 comma 2 comma 3 is okay, sorry, or respectively. Okay, individually at z equal to 1, z equal to 2, z equal to 3. Okay, individually find out cheyandi. Ikkada chudandi, z equal to 1. I am writing here, just I am intistani. For int, you have to observe clearly z is equal to 1 comma 2 comma 3 are simple poles and simple poles. Then residue of the function f of z అన్నప్పుడు z minus 1 అంటే ఇది టర్మ్ క్యాన్సిల్ అయిపోతుంది. z equal to 1 ఈ రిమైనింగ్ ఫంక్షన్ లో సబ్స్టిట్యూట్ చేయండి, సమ్ వాల్యూ వస్తుంది. అలా మీరు క్యాలిక్యులేట్ చేయండి. ఓకే, క్యాలిక్యులేట్ చేస్తే ఓకే, నేను ఆప్షన్స్ ఇక్కడ ఇస్తాను నేను. ఓకే, ఫస్ట్ ఆప్షన్ 4 comma 9/2 comma 1. Second option 1/2 comma minus 4 comma 9/2. This is 1. And third option 1/2 comma 4 comma minus 9/2. And fourth option కొంచెం కన్ఫ్యూజ్ చేస్తాడండి ఇక్కడ, జాగ్రత్తగా చూసుకోండి, ఆప్షన్ చెక్ చేసుకోండి. minus 1/2 comma 4 comma minus 9/2. ఓకే, ఇది ఏ ఆప్షన్ అనేది మీరు చెక్ చేసుకోండి. ఓకే, I can post on proof. Okay, with this maximum I covered all the problems of residues. Okay, now we go for another topic is ముఖ్యమైన ప్రాబ్లమ్స్ ఉంటాయి. రీసెంట్ గా సెట్ లో 2 ప్రాబ్లమ్స్ వచ్చాయండి. రీసెంట్ సెట్ లో ప్రాబ్లమ్స్ నేను చేస్తాను. యాక్చువల్గా నాట్ గెటింగ్ ఎగ్జాక్ట్లీ ఆన్సర్ రావట్లేదు, దట్స్ వై ఐఎమ్ నాట్ టేకింగ్. క్లియర్ గా చేసిన తర్వాత నేను గ్రూప్ లో పోస్ట్ చేస్తాను 2 ప్రాబ్లమ్స్. Now I'm taking another topic is zeros and Roche's theorem and argument principle. Okay. First, a basic definition of zeros. As we know that zeros of a function, zeros means nothing but roots. Okay. Now, if a function f of, we are taking a function. Yes, madam. Yes. Numerator. Yeah. Have question you can ask. లేకుంటే లాస్ట్ లో అడగండి. ఓకే. I'm taking ఆప్షన్స్ తర్వాత చూద్దామండి. ఫస్ట్ ఇక్కడ చూడండి. జీరోస్ మీన్స్ రూట్స్ అండి. ఇక్కడ రాసి జీరోస్. In other words, we call it as roots. సింగులారిటీస్ ఏం చేస్తామంటే న్యూమరేటర్ డినామినేటర్ ఇస్ జీరో చేస్తాం. జీరోస్ ఏం చేస్తామంటే ఆపోజిట్ అండి. న్యూమరేటర్ విల్ బి జీరో. ఆల్రెడీ we are explained. Let f of z is analytic function. First of all, I am taking f of z be analytic function. And we have condition, that is f of z0 is equal to 0 and f dash of z0 is equal to 0, f double dash of z0 is equal to 0, and so on and so on. F m minus 1th derivative at z0 is equal to 0. Up to m minus 1th derivative will be 0, and f mth derivative at z0 is equal to 0. In this case, we say that z equal to z0 is a 0, is 0 of order, is 0 of order m. Okay, of order m. The order mth derivative not equal to 0 ante of order m antam. Second derivative not equal to 0. Ikkada 0 ayindi undandi. Is not equal to 0. First f of z0 is equal to 0. F dash of z0 is equal to 0. But f double dash of z0 is not equal to 0. In this case, we say that z0 is a order 0 of order 12. Okay. Ante ila rasthunnanu. If f of z0 is equal to 0, f dash of z0 is equal to 0, and f double dash of z0 is not equal to 0, then z is equal to z0 is called a 0 of order m is equal to 2. Okay. Similarly, we can expand for m equal to 3, m equal to 4, m equal to, and so on. Okay. In case the first term, the functional value at z0 is 0, and the first derivative at this point is not equal to 0. F dash of z0 not equal to 0. In this case, z equal to z0 is called a 0 of order m is equal to 1. Okay. Just I am recalling, already we are discussing. A 0 of order m is equal to 1 is called simple 4. It is also known as simple 4. Okay. This is the basic definitions of residues. Okay. Now, when f of z is an analytic function, if you take f of z is analytic function in some neighborhood of z, that means in the domain modulus of z minus z naught is less than some r. Okay, I'm taking small r with the, it is a disk. In this disk, the function is analytic. We can expand this function according to Taylor's theorem. Then by Taylor's expansion, series expansion, we can write, or we have f of z can be represented as f of z is equal to f of z naught plus z minus z naught into f dash of z naught plus z minus z naught whole square by 2 factorial into f double dash of z naught plus and so on up to z minus z naught whole to the power of m minus 1 by m minus 1 factorial f m minus 1th derivative at z naught plus mth derivative I'm taking. That means z minus z naught whole to the power of m divided by m factorial f mth derivative at z naught plus and so on. As if we take a z equal to z naught is a pole of order m. Sorry, z equal to z naught is a pole of, sorry, 0 of order m. If z equal to z naught is a 0 of order m. In this case, f of z can be represented as up to this f of z naught is 0, f dash of z naught is 0, f double dash of z naught is 0, up to m minus 1th derivative will be 0. So remaining terms are z minus z naught whole to the power of m divided by m factorial into f mth derivative at z naught. The next term will be z minus z naught whole to the power of m plus 1 by m plus 1 factorial into f m plus 1th derivative at z naught plus and so. We can write like this. Next term. So in this case, we can take z minus z naught whole to the power of m as common. Z minus z naught whole to the power of m as common. Remaining terms are f mth derivative at z naught divided by m factorial. Second term, z minus z naught divided by m plus 1 factorial into f m plus 1th derivative at z naught plus and so on. Okay. So here f of z is equal to we can write z minus z naught whole to the power of m into some another function. It is analytic function g of z, where g of z is equal to f mth derivative at z naught divided by m factorial plus z minus z naught into f m plus 1th derivative at z naught divided by m plus 1 factorial plus and so on. Okay, ఇలా మనం రిప్రజెంట్ చేయొచ్చు. That means ఇక్కడ ఈ టర్మ్ ఎందుకు చెప్తున్నా అంటే that is means f of z divided by g of z value, that is equal to z minus z naught whole to the power of m అండి. while taking modulus on both sides, we get f of z divided by g of z modulus of this is less than is equal to modulus of z minus z naught whole to the power of m. Okay, modulus of z minus z naught whole to the power of m. This is less than or equal to, this is nothing but a constant. Okay, we are taking, actually we are given the domain is disk is modulus of z minus z naught is less than r. If we take r is equal to 1, or r is a any non-negative real number. If you take, we can take r is equal to 1 also. Okay, it may be 1. Okay, we are taking this is less than or equal to some constant that will be, I am taking for my convenient, I am taking 1. In this case, what happens? Modulus of f of z divided by, writing clearly, modulus of f of z divided by modulus of g of z is less than or equal to 1. That means here we have modulus of f of z is less than or equal to modulus of g of z. Modulus of f of z less than or equal to modulus of g of z. That means this condition satisfies. ఇది ఎలా వచ్చిందంటే ఈ కండిషన్ మనము f of z ను ఎక్స్పాండ్ చేయడం వల్ల ఇలా వచ్చింది కండిషన్. m equal to z equal to z naught is a 0 order m గా. సో దెన్ ఇక్కడ నుండి మనం రోచెస్ థీరాన్ని డిఫైన్ చేస్తాం. రోచెస్ థీరం, ఓకే, సారీ, రోచెస్ థీరం డిఫైన్ చేస్తాం. కండిషన్ రోచెస్ థీరం కోసం యూజ్ చేస్తాం. ఏం చేస్తాడంటే రోచెస్, దెన్ ది నెంబర్ ఆఫ్ జీరోస్, ది నెంబర్ ఆఫ్ జీరోస్ ఆఫ్ f of z plus g of z is equal to the number of zeros of g of f of z. అంటే ఇందులో ఏ ఫంక్షన్ అయితే స్మాలర్ వాల్యూ ఉంటుందో అంటే f of z less than or equal to modulus of g of z కండిషన్ సాటిస్ఫై అవుతుందో, ఈ కేసులో the function the number of zeros of f of z plus g of z will be the number of zeros of g of z. g of z zeros find out చేస్తే సరిపోతుంది. మనం కంప్లీట్ గా f of z g of z కండిషన్ ఈ మొత్తం జీరోస్ ఫైండ్ అవుట్ చేయాల్సిన అవసరం లేదు. జస్ట్ g of z జీరోస్ ఫైండ్ అవుట్ చేస్తే సరిపోతుంది. దట్ విల్ బి ఈక్వల్ టు నెంబర్ ఆఫ్ జీరోస్ ఆఫ్ f of z plus g of z. దిస్ ఇస్ కాల్డ్ రోచెస్ థీరం. రోచెస్ థీరం, ఓకే, వెరీ ఇంపార్టెంట్ థీరం. దీని నుండి ప్రాబ్లం వస్తుంది. ఎలా ఇస్తాడంటే ఫైండ్ ద నెంబర్ ఆఫ్ జీరోస్ ఆఫ్ ది ఫంక్షన్ ఇన్ ద ఏంటి సర్కిల్ ఇస్తాడు. ఓకే, ఫస్ట్ ఐఎమ్ రైటింగ్ ద స్టేట్మెంట్ హియర్, క్లియర్ స్టేట్మెంట్. లిసన్ కేర్ఫుల్లీ హియర్. రోచెస్ థీరం, here I am taking f of z and g of z. f of z and g of z are analytic inside and on C, inside and on C, and satisfies the condition modulus of f of z is greater than modulus of g of z. Okay, in clarity okay, modulus of f of z is greater than modulus of g of z on C, then f of z plus g of z and f of z. మనకు అర్థం కావడం కోసం నేను ఇలా రాస్తున్నా. అండ్ అని చాలా సార్లు వస్తుంది. f of the condition you have to remember, modulus of f of z is greater than modulus of g of z then f of z plus g of z and f of z have the same number of zeros, have the same number of zeros inside C. Inside C. That inside here. We need to calculate just f of z zeros. If we calculate f of z zeros, we can say the entire polynomial zeros. Okay? You have to remember the condition. ఏదైతే maximum value ఉంటుందో ఆ maximum value యొక్క zeros find out calculate చేస్తే సరిపోతుంది. But here we have to be very careful. Be careful about taking f of z and g of z. మనకు polynomial ఇస్తాడు p of z. Okay, some polynomial z square plus 2z plus 1 ఇలా ఇచ్చాడు. సింపుల్ polynomial తీసుకుందాం. Okay, now ఇక్కడ polynomial ఇచ్చేసినప్పుడు మనము ఏంటి సపరేట్ చేసుకోవాలి. ఐదర్ ది కండిషన్ modulus of f of z is greater than modulus of g of z కండిషన్ సాటిస్ఫై అవుతుందా లేదా చెక్ చేసుకోవాలి. ఓకే, ఇలా చెక్ చేసుకున్నాం అనుకోండి, అప్పుడు ఇక్కడ అంటే మనం ఇక్కడ స్ప్లిట్ చేసుకోవాలి. ఎఫ్ ఆఫ్ జెడ్ ను, ఇది పి ఆఫ్ జెడ్ అండి, ఎఫ్ ఆఫ్ జెడ్ ను ఇలా తీసుకున్నా నేను, జి ఆఫ్ జెడ్ ని ఇలా తీసుకుంటే ఈ కండిషన్ సాటిస్ఫై అవుతుందా లేదా చెక్ చేసుకోవాలి. ఒకవేళ సాటిస్ఫై కాలేదు, ఇలా ఉంది, మాడ్యులస్ ఆఫ్ ఎఫ్ ఆఫ్ జెడ్ ఈజ్ లెస్ దెన్ మాడ్యులస్ ఆఫ్ జి ఆఫ్ జెడ్ ఇలా ఉంది. In this case, we say that the number of zeros of f of z plus g of z has the same number of zeros of g of z. ఇక్కడ maximum value ఏంటి, g of z కాబట్టి g of z values కు ఈక్వల్ అవుతుంది. ఓకే, దిస్ ఇస్ ద కండిషన్. అంటే ఫస్ట్ మనం కన్స్ట్రక్ట్ చేసుకోవాలి. ఇప్పుడు యాక్చువల్గా వన్ సెకండ్, నెక్స్ట్ అదే పాయింట్ చెప్తాను. ఇక్కడ మీరు ఎక్కడైతే మాక్సిమం వాల్యూ ఉంటుందో ఆ మాక్సిమం వాల్యూకు ఆ ఫంక్షన్ యొక్క క్యాలిక్యులేట్ చేస్తే సరిపోతుంది. అంటే ఇదే కండిషన్ నేను రాస్తాను. అనేదర్ స్టేట్మెంట్ ఇక లెట్ ఎఫ్ ఆఫ్ జెడ్ అండ్ జి ఆఫ్ జెడ్ ఆర్ అనలిటిక్ inside and on C, and also modulus of f of z is less than, లేకుంటే ఇక్కడ నేను g of z అని తీసుకుంటాను. modulus of g of z is greater than modulus of f of z on C. Then f of z plus g of z and g of z have the same number of zeros, same number of zeros inside C. Okay, condition ఇక్కడ మారింది చూడండి. ఇక్కడ modulus maximum value is modulus of f of z. Okay, here maximum value is modulus of g of z. So here we need to calculate zeros of f of z. Here we need to calculate zeros of g of z. In this case, number of zeros of f of z plus g of z will be f of z, and in this case the number of zeros of f of z plus g of z will be maximum value, that is number of zeros of g of z inside the circle C. Okay, so I am taking from this we can calculate first the standard definition statement and the standard statement for మన కన్వీనియంట్ కోసం ఇలా మార్చుకుందాం. ఓకే, యాక్చువల్లీ నేను ఫస్ట్ స్టాండర్డ్ డెఫినేషన్ నుండి ఇలా తీసుకుందాం. లెట్ మాడ్యులస్ ఆఫ్ ఎఫ్ ఆఫ్ జెడ్ ఈస్ గ్రేటర్ దెన్ మాడ్యులస్ ఆఫ్ జి ఆఫ్ జెడ్ ఆన్ సి కదా కండిషన్. ఫ్రమ్ దిస్ వీ కెన్ రైట్ modulus of g of z is less than modulus of f of z. Okay, just I'm changing the values here. Okay, so on C as this, there is no change here. So we can write it as modulus of g of z divided by modulus of f of z is less than on C. Okay. So from this we can write modulus of g of z divided by f of z is less than 1 on C. Okay. And we have to calculate, we have to choose g of z and f of z such that modulus of g of z by f of z is less than 1. ఇలా అయ్యేటట్టుగా చూస్ చేసుకోవాలండి. అకార్డింగ్ టు ప్రాబ్లం దెర్ ఇస్ నో స్పెసిఫిక్ లాజిక్. Just you have to verify whether the condition is satisfied or not. Modulus of g of z by f of z is less than 1, or otherwise the another condition is modulus of f of z by g of z is less than 1. In this case, we have to say that the number of zeros of f of z plus g of z is equal to number of zeros of f of z. ఈ కేసులో ఓకే, ఇలా ఉందనుకోండి, modulus of g of z divided by modulus of g of f of z divided by g of z is less than 1 on C అయిందనుకోండి. In this case, we have to say the number of zeros of f of z plus g of z will be equal to the number of zeros of g of z. This is the logic. Okay, we have to verify, we have to choose. Choosing very important అండి. ఎలా చూస్ చేసుకుంటున్నాం అనేది ఇంపార్టెంట్. Okay, first I am taking one problem, sample problem. The number of zeros అనొచ్చు, లేదంటే రూట్స్ కూడా అనొచ్చు అండి, ఎలానా సేమ్. ఫస్ట్ ఐఎమ్ టేకింగ్ వన్ ప్రాబ్లం. ఇక్కడ ప్రాబ్లం చేస్తే మీకు క్లియర్ వస్తాయి. సింపుల్ ఎగ్జాంపుల్ తీసుకున్న తర్వాత ప్రీవియస్ క్వశ్చన్ డిస్కస్ చేద్దాం. ది నెంబర్ ఆఫ్ జీరోస్ of f of z is equal to z power 5 plus 4 z power 4 plus 3i inside C. Modulus of z is equal to 2 is. In this circle, we have to calculate the zeros. Complex plane, real and imaginary axis. Center is the origin and the radius will be 2. So this is a circle. Okay, you take it as a circle. -1, -2. It is not ellipse, it is circle. 1, 1, 2. This is the radius. Okay. So first I am taking, actually it is a polynomial of degree 5. For this polynomial we have 5 zeros. We have to calculate inside the circle. In this circle we have to calculate how many zeros to be exist inside the circle. Okay. This is a circle. Modulus of z is equal to 2. Okay. So first of all, I am taking f of z is equal to I'm taking letter. This is f of z అని ఇచ్చాడు. నేను f of z కాకుండా ఇది p of z అని తీసుకుంటాను. p of z is equal to z power 5 plus 4z cube plus 3z. I'm taking f of z is equal to 4 into z power 4 and g of z is equal to remaining function z power 5 plus 3i. Then by definition, then modulus of f of z, that is equal to modulus of 4 z power 4, that is equal to 4 into modulus of z whole to the power of 4 is equal to 4 into modulus of z is equal to 2 kada, 2 power 4, 2 power 4 16 it is 64. Okay, modulus of f of z value is 16. And modulus of g of z value, that is equal to modulus of z power 5 plus 3i. This is by triangle inequality, modulus of z power 5 plus modulus of 3i. This is less than or equal to mod z power 5 plus 3. Modulus of 3 is 3 and modulus of 5 is 1. That's why I'm writing 3. And z power 5, modulus of z equal to 2 power 5 plus 3, 32 plus 3, it is 35. As we know that, therefore, we can say that modulus of f of z will be greater than, strictly greater than modulus of g of z. Okay, on C. So we have to calculate the zeros of f of z only. Okay, so therefore f of z is equal to 4 into z power 4 as 4 zeros inside C. Inside 4 zeros inside C. Therefore, f of z plus g of z. Therefore, p of z actually we are given, that is p of z, that is equal to f of z plus g of z. That is nothing but z power 5 plus 4 z power 4 plus 3n as 4 zeros inside C, inside the circle C. Okay, this is the idea. Ikkada z power 4, f of z equal to 4 into z power 4 and g of z is equal to z power 5 into plus 3i. ఎలా అంటే కండిషన్ ఎలా, ఐదర్ modulus of f of z is greater than 0 or modulus of g of z is, modulus of f of z is greater than modulus of g of z or modulus of g of z is greater than modulus of f of z. ఆ కండిషన్స్ లో ఏదైనా ఒక కండిషన్ సాటిస్ఫై అయ్యేటట్టుగా we can choose the f of z and the g of z values. Okay, now I am taking another problem here, another example. The number of zeros of ఇక్కడ z equal to 4 అంటే as 4 zeros, ఆ 4 zeros ఏంటంటే 0, 0, 0, 0. ఓకే, ఈ 4 కూడా ఇన్సైడ్ ఏ ఉంటాయండి, 0 అంటే ఇన్సైడ్ ఏ ఉంటాయి. ఓకే, now I am taking another example. The number of zeros of z power 7 minus 5z cube plus 12 inside the circle, modulus of C modulus of z is equal to 2 R. First, we have to take the given function as p of z. P of z is equal to given polynomial, that is z power 7 minus 5z cube plus 12. The circle is same circle, previous circle, center at origin and 2 units distance, 1 and it is 2. Okay, so we have to choose f of z and g of z. Okay, I'm taking or putting f of z is equal to z power 7 and g of z is equal to minus 5z cube plus 12. So then modulus of f of z value is modulus of z whole to the power of 7. 2 power 7 అంటే 2 power 6 అంటే 64 into 2 128. Okay, so and modulus of g of z, modulus of g of z, that is equal to minus modulus of minus 5 cube plus 12, 5z cube plus 12, that is less than or equal to 5 times of 5 times of modulus of z whole cube plus modulus of 12 అంటే 12. This is less than or equal to 5 into 12. Sorry, 2 cube, that is 8 plus 12, 40, and it is 52. Okay, absolutely we can obviously we can say that modulus of f of z is strictly greater than modulus of g of z on C. Okay, so we have to calculate the zeros of f of z. Therefore, the zeros of f of z is equal to z power 7 and 7 zeros are as zeros of f of z is equal to z power 7 or 7 zeros, 0 0 0 0 0 0 0 inside C. Okay, so we have to say the number of zeros of p of z. Therefore, number of zeros of p of z is equal to that is f of z plus g of z. F of z plus g of z is equal to also 7. Okay, so 7 zeros are exist inside the circle. Modulus of z is equal to p of z is equal to z power 7 minus 5z cube plus 12. Okay, ఇక్కడ చూసింగ్ ఇంపార్టెంట్ అండి, ఎలా చూస్ చేస్తున్నాం. ఓకే, f of z, g of z ను ఎలా మనం చూస్ చేసుకుంటున్నాం, ఎలా స్ప్లిట్ చేసుకుంటున్నాం అనేది ఇంపార్టెంట్. ఇక్కడ నేను f of z ఈక్వల్ టు z పవర్ 7 కాకుండా z పవర్ 7 ప్లస్ 12 చూస్ చేసుకున్నాను అనుకోండి, దీనికి ఏంటి జీరోస్ క్యాలిక్యులేట్ చేయడం కొంచెం ఇబ్బంది. కాబట్టి మనకు క్లియర్ గా తెలుస్తుంది మోడ్యులస్ ఆఫ్ z కు జీరోస్ ఏంటి 0 0 0 0. ఓకే, ఆల్రెడీ మన సర్కిల్ ఏంటి మోడ్యులస్ ఆఫ్ z ఇస్ ఈక్వల్ టు 2. ఈ 0 అనేది ఇన్సైడ్ లో ఉంటుంది కాబట్టి, అంటే బై ఐడియా. ఓకే, ఈ ఐడియా నుండి మనం కన్స్ట్రక్ట్ చేయాలి. కన్స్ట్రక్ట్ చేసిన తర్వాత ఈ కండిషన్ సాటిస్ఫై అవుతుందా లేదా చెక్ చేయాలి. ఇలా కాకుంటే మనం స్ప్లిట్ చేసుకోవాలి, ఇంకో కండిషన్ చూస్ చేసుకోవాలి. ఓకే, లేదంటే మీకు లాజిక్ చెప్పానుగా, మోడ్యులస్ ఆఫ్ f of z బై g of z ఈజ్ లెస్ దెన్ 1 కండిషన్ అయ్యేటట్టుగా, లేదంటే మోడ్యులస్ ఆఫ్ g of z బై f of z లెస్ దెన్ 1 అయ్యేటట్టుగా వీ హ్యావ్ టు చూస్ అకార్డింగ్ టు సర్కిల్. సర్కిల్ మీద డిపెండ్ అయి ఉంటుంది చూసింగ్ అనేది. ఓకే, దాన్ని బట్టి మనం చూస్ చేసుకుంటాం. ఓకే, with this today I conclude. We have in the next class we'll continue the zeros. Okay, మనం ప్రీవియస్ క్వశ్చన్స్ చూద్దామండి, అండ్ కొన్ని ఇంపార్టెంట్ టాపిక్స్ క్వశ్చన్స్ చూద్దాం. ఇఫ్ యూ హ్యావ్ క్వశ్చన్స్ ఇన్ దిస్ క్లాస్
సార్, ఇక్కడ సింపుల్ గా మనం